Hello, this video clip is going to be about hyperbolas. We're going to be looking at remembering what the different vocabulary words are that relate to hyperbolas, and then also how to find the equation of a hyperbola if its center is not 0, 0. So let's jump in with the vocab. Hopefully you're remembering this picture from class on Mondays. So we see here that I have focus set up, vertex, center. Similar to our work with the ellipses, we notice that there's symmetry going on around here. The axis that goes through the focus, the vertex, the center, that is called my transverse axis. And the axis that runs perpendicular to that is my conjugate axis. These two pieces are called my branches. Okay, it's important that we remember that the value A is the distance from the center to the vertex. The distance B is going to be the distance from the center along my transverse axis as well as my conjugate axis. And my distance C is going to describe my distance from the center to the foci. So, some basic things that we need to remember and be confident in. Alright, now in your books you also have this valuable table 4, right? This is just a reminder, but something that we're going to be making use of here momentarily. If my transverse axis is parallel to my x-axis, this is my base equation that I'm going to make use of. Okay, it's going to be x minus h, right? I'm describing the center with that. The h is the x value of my center, squared over a squared minus y minus k squared over b squared equals 1. Remembering that b squared is equal to c squared minus a squared. Alright, and my asymptote can be described in the following fashion. Y minus k equals plus or minus b over a times x minus h. Okay. If my transverse axis is parallel to my y, notice I have a variation here. Now I have y minus k comes first over the a squared value minus the x minus h squared over b squared equals 1. Right? This is staying the same. Notice with my asymptote now, instead of being b over a, my asymptote is now found as a over b. Right? This can be found on table 4 if you need a reminder on that to see that. Okay, base information that we're going to make use of. So let's look at an actual situation where I am given 3 pieces of information and I need to discuss the hyperbola. So here it is. Alright, in this problem, I'm given that I have a center of 4, negative 1. I have a focus of 7, negative 1, and a vertex of 6, negative 1. I have graphed for us those points on my board here. You and I might notice that this looks like it is parallel. The transverse axis is going to be parallel to my x-axis. Okay, so I'm parallel to my x-axis in this problem. Therefore, my equation I'm going to make use of is x minus h squared over a squared minus y minus k squared over b squared. Here is my equation, okay, which I've taken from the board we just looked at, those equations. So let's start to put in the information that you and I know for sure. Alright, a is my distance from the center to the focus. So in this situation, my v, my a, distance there is 2. So I know that my a squared is 4 because 2 squared is 4. I also know that my x value of my center is 4. So I have x minus 4 squared set up there. Okay, that's just showing my x value. Likewise, I can go y minus, it's going to become a positive 1 because my y value is negative 1. Okay, over, well, you and I need to solve for b squared. So, b squared is going to be c squared minus a squared. All right, my C distance from the center is 1, 2, 3, so that makes it 9 minus 4 equals 5. So the equation of my parabola is this. Okay, there I've got, that's my a squared, and here is my b squared. All right, so we're like, great, I've got my equation. Now I need to start thinking about how I'm going to graph it. At this point, you and I can make use of the asymptote. So let's look at what is the asymptote. There's going to be 2 lines here of my asymptote. So at this point, you and I also know that the b value is the square root of 5. Okay? The way that helps me is I come over here to my center, and I know that if I go over the square root of 5 is going to be a little bit more than 2, right? Because the square root of 4 is 2, so the square root of 5 is a little bit more than 2. So if I go up, I'm going to go up 1, 2, I'm going to go up the square root of 5, and I'm going to go down the square root of 5, approximately. Work with me on that, okay? And now I can draw, I'm going to draw a little box here. This box is going to go as such, right near my vertex, okay? Okay, this is like showing where my branches are not going to end up, okay? Now, the equation of my asymptote is going to be y minus k equals plus or minus b over a x minus h. Okay. So now I'm going to substitute in those pieces of information. So y plus 1 equals plus or minus my b value, right, is the square root of 5. My a value is 2 times x minus the h value is 4. This right here is the equation of my 2 asymptotes. Okay? Now, interestingly enough, I can draw those asymptotes as such through my diagonals of this box. Okay? Now remember, an asymptote is a line that my branches are going to approach but not actually touch. Okay? One way to get some exact values for the shapes of my, I'm just going to make these dotted so that we don't get them confused with our branches that we're about to graph here. Make those dotted. Okay, those are my asymptotes. Now, if I were to take the x value of my focus and substitute it into my equation, okay, for x, I could solve for the y values that are associated with this focus. Okay, if you were to do this, you would find out that from this focus, I need to go up to when x is 1.5, and I would need to be down here when it's negative 3.5. If you try that, you'll see that. And then my branches are going to come through. Just going to mirror this over here. Whoops, that's not mirroring very well. Mirror it over here, okay? And show my branches. Okay, but those branches are never going to touch my asymptotes. So I can draw in those asymptotes using the little box I've created there. And then if I substitute in this case, my x value into my equation, I can find the y values associated. And if you were to try that at home, you would find out that this value is, let's see, the focus value was 7, and 1.5, or 7, negative 3.5. Right? And given symmetry, we can draw in those the other branch there. So I hope you find that helpful. All right, we're going to be practicing this tomorrow in class. It's really important you watch this at least once, maybe twice, so that you've got the vocab down and can really work with it. Have a good night.